In this video, we're going to talk about some advanced tools for data visualization on top of the tables and graphs that we can use in Excel. For this one, we're not going to use any, uh, we're not going to display anything in Excel. We're not going to use Excel, but these are just for your information and you're expected to know them for the exam. So examples like parallel coordinate plot. This is a chart for examining data when you have more than two variables and you usually want to compare multiple groups, multiple classes of the population, multiple subsets of the population, but based on multiple variables, right? So for example, if you want to compare females versus males, but in terms of um, a few quantitative variables like age, GPA, like let's say the arrival time to the class. So these are some quantitative, like delay to the class. Uh, these are some quantitative factors that you may want to compare female versus male students in a class or in a population, right? So the example of that in on this slide will be this graph. When we have two groups of players in baseball, first base players and second base players. We identified the first base players using the blue colors and second base players using the red colors. And we have three factors here. We have the number of home runs, we have the stolen bases, and we have the uh, batting average, basically. And for each one of these people, let's say we have 10 person, 10 players in each group. For each one of them, we record the number of home runs and we just put, put a dot here, the number of stolen bases, put a dot here, connect these two dots, and connect to the number of basically batting average, players batting average. We just, as you can see, the units here are completely different. Here, the numbers are between 0.22 and 0.34, for example. Here, the numbers are between 1 and 30 or 0 and 40. Right, so the magnitude of the numbers, the scale of the numbers are completely different. As long as they're numerical, you can do this. And then at the end, once you do this for everyone, for every player in the group, for in the first and second group, it helps you to visualize the difference between these two groups in terms of each one of these factors, right? So now you can see the first base players are actually they get higher number of home runs compared to the second base and so on. So that's one way to visualize when you're comparing multiple groups, here two groups, in terms of multiple factors, and usually when you have different scales, different magnitudes, right? The second tool that we're going to talk about is called Treemap. This one, you can actually do it in Excel. This is great when you want to visualize the hierarchical data along multiple dimensions. Hierarchical data, when you have, for example, a quantitative factor for different classes of population, and you can classify the population using multiple factors. For example, here this is a good example of a tree map. In this is a very simple one. We have different sectors of the market. So each large triangle that you see is a different sector. we have the healthcare, we have financial, oil and gas, and so on. And then within each, right, so that's one hierarchy, the first level, sector. The second level can be industry. We don't have it here, but it can be. The third level can be the size. It can be large cap, medium cap, or small cap, or micro cap. You may have, so you see that there can be different hierarchies: sector, industry, and then size of the market cap, right? And then within each smaller triangle, you may have much smaller triangles, and each small triangles correspond to the market cap of each company, or it may actually correspond to your share in each one of these companies, or dollar value that you have invested in these companies, right? And then the color here would correspond to the change in the price. I mean, in this example, but it can be anything, right? As long as you have different hierarchies, and as long as there is a quantitative factors at the end of the day, here it would be price of stock, but it can be anything. It can be timeliness of your suppliers. It can be sales or orders by your customers. You may have different regions. You may have different channels, sales channel. You may have online. You may have, let's say, online channel, retail channel, wholesale channel, for example. And then each retailer in each one of these, sorry, each customer using each one of these um, channels from each one of these regions that you are operating, the sales volume at the end, right? And then you may use colors to identify increase or decrease, or whatever that you are interested in knowing. The next graph would be geographic information system, GIS. This is a graph that basically integrates maps and statistics. So this instead of showing numbers for different regions in a table format, you can use maps. And instead of just having the name of the region or sub-region, you can have the actual map for each sub-region. And instead of using the actual number, you can associate numbers with different colors, something similar to what we did uh, uh, similar to the concept of heat maps, right? So you may want to associate, you may want to allocate different shades of color to different numbers. And then instead of just typing a number in front of the region name, you can just color the region map. And then when somebody looks at the map, in terms of the darkness or lightness of the shades of color on different regions on the map, they can see if the density is larger, or the volume, sales volume from a region is larger than the other. This is a very interesting tool nowadays for identifying the demographic and geographical factors and geographical analysis of the markets. The next one would be data dashboards. So data dashboards are increasingly popular nowadays. These are similar to the reports, except that these are usually data dashboards are a short summary of data, usually large volumes of data, but in a few visuals. And these are the difference between dashboards and reports is that dashboards are usually connected to the database. And when something happens to your data, to your data source, to your database, the dashboards get automatically updated. Whereas if you're working on a report, static report, you may have to get back to your report and update it. Whereas the dashboards are usually connected to the database, and if something happens to your database, they get automatically updated. All right. And the way that dashboards work, usually for a specific type of audience, you may want to identify some key performance indicators, KPIs, all those factors that determine and define the performance of a system. So you need to know those, and then you just need to quantify and basically characterize those KPIs using the data that you have in your database. So you may want to have a graph or table that shows, for example, the current speed for automobile dashboard using the data file that you have. So you need to first identify the KPIs, then identify the fields that can characterize these KPI. And you may want to also write some formulas, some codes, and just to merge, just to combine those factors, and hopefully just to accurately compute these KPIs that you're looking for, and then put it in a graph or table that is useful for the reader, right? I'm gonna leave these items to you guys to read through. And this is an example of a dashboard. It's usually in 1 or 2 pages with multiple graphs, and each graph usually addresses the same data from a different angles. Usually each one of these graphs corresponds to one KPI, one of these factors that is interesting to the audience, to the reader of the dashboard.